Hi everybody, this video today is going to cover lesson 4.5 on function notation and evaluating. So when we talk about function notation, what we're talking about is f of x. That's the main thing. And so we all know what y equals means, but we're going to replace it now with f of x. And f of x is just the name of a function. It could also be g of x or h of x or almost any letter, but it was just f of x because it's for function. So y equals 5x plus 1, we kind of understand what that means, right? Like that's our input, and we plug it in and we see what we get for the output. Well, that's going to be the same thing as f of x equals 5x plus 1. All I did was I changed the y and I changed it into an f of x. It means the exact same thing. I do want to say that f of x does not mean multiply. Sometimes in the past you might have used something like this, like let me show you an example. You don't need to write this down, but sometimes people write this, and what that really means is 2 times 3, which is 6. This is not a multiplication. And how do you know the difference? Well, you just kind of have to think about it in context. And so on this kind of a problem, obviously it's all numbers, but on this kind of a problem, it's probably going to be mostly letters. So just understand that it does not mean multiply. It just means f of x, which is the same thing as y equals. A lot of times we refer to functions as an input-output machine. And so you put in something like a number, and then you perform this rule, and then it has an output of a certain answer. And so for instance, if we have this, y equals 3x plus 2, and we say evaluate it for x equals 5, well, first of all, there's going to be several transformations. One thing is we could just say f of x is equal to 3x plus 2. But then this x equals 5 business, what that means is we can plug in a 5. And so we can say f of 5 is 3 times 5 plus 2. Now notice it's kind of like that thing I just looked at a second ago. This one's not multiplication, but this one is multiplication. It's kind of confusing. You just have to pay attention to context clues. And then we would go ahead and simplify this. So on the left, we just keep it as f of 5. But on the right, that would be 15 plus 2, which is 17. And so our final answer on that problem would just be that f of 5 is 17. Now let me talk about that in terms of the input-output. What that means is the 5 was the input. We put it into the x. And the 17 was the output. That's what makes it a function. We have input and output. Let's look at the next one. Again, we're first going to change this into an f of x instead of a y, and then we're going to plug in a 10. And so we just plug in a 10 for this x, and we plug in a 10 for this x, and then we simplify it. And that's going to be a negative 20 minus 6, so f of 10 is negative 26. And so again, that's our function rule. That's our input-output. If you put in 10, you'll get out negative 26. Okay, this one doesn't make a whole lot of sense. It's kind of silly. But we would start with saying, okay, f of x is equal to 1/2 x minus 7. And it says for x equals dog. So I'm going to say the f of the dog, which doesn't make much sense, is 1/2 of a dog minus 7. Okay, it just makes no sense. So one thing we think about when we talk about functions is the domain. That is, what could you plug in? So dog is the wrong domain. We can't take 1/2 a dog. It doesn't make any sense. But over here, 5 works, that's part of the domain. 10 works, that's part of the domain. Dogs, not part of the domain. Okay, evaluating function is, we just did a bunch of it. We might not have to do all of these because we just did a bunch of it up here. But what it means is to substitute the value in for x. Usually it's x, the variables that we use. So for instance, f of 5 is 5 plus 7. So f of 5 is 12. Input is 5, output is 12. All right, input is 5, output of 12 means that this really could be written as a coordinate because that's input-output. Input 5, output 12. Let's look at another one. G of 1 is 3 times 1 minus 8. We could simplify that and say that g of 1 is -5. And that's our final answer. Once again, if we wanted to, we could say 1, -5. Put in a 1, you get out a -5. Okay, last problem here. Putting in a -3. 2/3 times -3 minus 1. Okay, you might not know how to multiply that, but that, when you multiply it, those 3's cancel out. You can do it on your calculator. And it would give you a -2 minus 1. And so h of -3 has an output of -3. It wants us to do 3 more of these, but you know what? I think we've covered enough. If we need to do some of these in class, we can do that. Let's go to the next page. Oh, before we go to the next page, let's notice that, remember I said that it could be f of x, it could be g of x, it could be h of x. So the letter in front, it could be anything. All right, since we skipped some of the negatives on the other side, maybe we can do some of the negatives over here. Let's do the bottom ones. Since we did the top ones on the other side, let's do the bottoms here. So I'm going to say f of -4 is equal to, now, especially when I plug in a negative, really when you plug in any number, but especially when you plug in a negative, you want to use your parentheses. And so when I plug this into my calculator, I have to be very careful with my parentheses, because this means -4 times -4, and that's a positive 16. And so we get f of -4 is equal to 12. Input -4, output 12. Okay, we're going to, like I said, we're going to skip that top row. We're just going to do the bottom row. G of 0. All right, 0, you know what, is my favorite one to do. You know why? Because it's super easy. Because I happen to know that 0 times anything is 0. 0 squared is 0. 0 times 3 is 0. And so we get g of 0 is equal to 7. And once again, that could be input, output, could be 0, 7 like this. Okay, we haven't talked a lot about absolute value. So remember that the absolute value bars means they're kind of like parentheses, because you do everything inside of them first. But then once you've finished everything inside simplifying, then you make it positive. So when I do this, I'm going to plug it in. 2 minus 4 times 4. I might go back and do this A version also, just because we haven't done it yet. So 2 minus 4 times 4, that's 2 minus 16. That's the absolute value of -14. Now, absolute value, what I just said a second ago, is that means you make it positive. And so our final answer, h of 4 is 14. You plug in a 4, you get out a 14. I want to do the other one up above because we haven't done very many absolute value. So this will give us some good practice with absolute value. So I'm going to plug in my -5. And when I plug in a negative, I always want to use my parentheses. Now this time, a negative times a negative gives me a positive. So that's 2 plus 20. And so that's the absolute value of 22. Well, the absolute value of 22 is just 22. And so the output is 22. If we think about the range, remember the range is the output? Our range has to always be positive, doesn't it? Because it has absolute value. So our range as our output is always going to be positive. Okay, let's look at an example. This time we have a word problem. Let's just read through the problem and then kind of break it up and see what we need to do. Anthropologists use the length of the femur bone of a human skeleton to estimate the height of a living person. To estimate the height in centimeters of a female with a femur length of x, this is the function that we're going to use. It says find h of 46. Okay, remember, all that means is we're going to take anywhere where there's an x, we're going to plug in a 46. Okay, so I plug that in my calculator, I get 168.13. All right, what does that mean in context? This is a really good question. So we have to go back and look at the problem again and read through. Okay, it says to estimate the height in centimeters of a female with a femur. Do you know what the femur is? It's like your thigh bone. The femur of length x, this is the function we're going to do. Now that we've read that through, what do you think h stands for? Do you think h stands for the height? And they tell us what x is. X is the femur length. And so what this means in context is, and I'm just going to write this out in words. Okay, so it means the height of a female who has a femur length of 46 centimeters, their height is 168.13 centimeters. it might be, my second sentence might make more sense. If your femur is 46 centimeters, then your height is 168.13 centimeters. That was just what the anthropologists, they had dug up a bunch of bones, and when they did all the bones, this is what they came up with. All right, finally, we can use graphs also to talk about functions. And we've talked about like the vertical line test. So functions and graphs go together as well. And I personally, once again, I like graphs because you don't have to do the math. Like you just have to be able to read the graph, which is its own skill, but you just have to do that. So f of -3, remember that this number is your x number. That's for your x-axis. So here's my x-axis, here's my y-axis. And this number is like your input, and your y number is your output. So if we put in a -3, I'm going to go to my graph, I'm going to go to x-axis, go to -3. Okay, here's -3 on my x-axis. The only point that I see there is this one. And where is that on the y? Because that's my output. So I want to look for it on the y-axis. Well, I don't know if you can tell, but we're counting by twos. This goes 0, 2, 4. So it's a 1 in the middle here and a 3 in the middle here. And so yeah, that's 1. Go over -3. Where do you have a point? You have one at +1 in the y's. Okay, let's go to another one. How about +1? Okay, we're going to go over to +1. Here's +1. The only point I see there is down here. That on the y-axis is -2. Okay, f of -3, or excuse me, +3. So that's my x. I'm going to go to my x, go to 3. There it is. I need to know what is the y value. Well, there's actually 2 of them. This is not a function, is it? Because there's one here, and there's also one there. And so f of -3 is both 0, again, it's the y-axis, and also 2. Goes up 0, goes up 2. Not a function. Okay, and then you can also look at it the other way, like the backwards way. Think about it the other way around. So what I'm saying is they want to know what input would have an output of 4, or what x would have a y value of 4. So I'm going to go to my y value and go to 4, which is way up here, and here's my point. Okay, what x does that correspond to? And it corresponds to a 2. What that means is if you have a 2 in the input, you have a 4 in the output. All right, same thing on this one. We're just going to go a little bit faster maybe. -4, here's my -4. Where's the graph? The graph is right here. The difference is over here we had dots, and over here we have a whole line. And so there's my -4, so how high is that? That goes up 2. Okay, 0, 0 is right here. So 0, 0. Remember I said a little bit ago that these can be stated as an input-output, which means it's a coordinate. So this means that -4, 2 is the point. And here's my point at -4, 2. And here's my point at 0, 0, because 0, 0. Okay, how about +2? Here's my +2. I'm going to go down and see where it hits the graph. It hits it here at -2. And so again, this coordinate is 2, -2. That goes with those two numbers. How about 5? F of 5. 1, 2, 3, 4, 5. I have to go to 5 on the x-axis, and that hits right down there, which is at -1. I kind of drew too much stuff in there. I'm going to erase that so we can see it a little bit better. But f of 5 is -1. And then last question, what is the input when the output is 4? Or in other words, what is the x when the y is 4? Well, let's go up to the y's. 0, 1, 2, 3, 4. Here's 4 on the y-axis. What is my x that corresponds to it? It's right here, and that is -1, -2. In other words, I put in a -2, I get a 4. Okay, that's what you need to know about evaluating functions and function notation. I know that some of that function notation gets a little bit confusing just because it's different than the y, but it's really the same. It's not a whole lot different at all. Okay, we will work on this together in class.